Another handy accessory in the machine shop is a surface plate or layout table. They come in granite and steel. You can get them in a variety of sizes and different grades. We have tool room grade, inspection grade, laboratory grade. For all practical purposes, outside of satisfying one's ego, any tool room grade will work just fine for 99.99% of all of the layout and inspection work that you may encounter. If you feel that you need a laboratory grade, keep in mind, in order to take advantage of the laboratory grade's flatness and uniformity, you're going to need to keep that surface plate in a controlled environment, free from dust and at a temperature of around 68 to 72 degrees. All right, enough said on that. Let's move on to the usefulness of the surface plate. We can have a height gauge. Again, a nice accessory. The height gauge allows us to perform some very complicated layout projects fast and efficient. If we've got some blocks that we need to lay out, as in this one that we've die-cummed as an example, we want to lay a hole pattern out, we'll simply adjust our scribe to a specific height, hold our block on, just drag the contact point across it, and scribe the reference lines that we need to drill holes, mill slots. Whatever the case may be, if we wanted to drill, tap holes, cut slots along those reference lines, it's a very fast and efficient tool. Also, if we want to check the height of something and use it as a go, no-go gauge, we simply adjust our height gauge and contact to our specified tolerance. It's a little bit tight there. And it simply becomes a go, no-go gauge at this point. It's got a vernier scale reading on the side. We talked about that earlier. It's got a nice magnifying lens, which is a handy feature, allowing you to very precisely locate and read the exact amount of thousandths that we are scribing or gauging off of. Let's take a look at a sign bar. We've talked a lot about angles, how to set them up. We haven't really gone over the sign bar. This is an example of a sign bar. Keep in mind that all sign bars are based on a 5-inch measurement from the contact points. And simply by looking up our trigonomic factors in the logarithm sections, we will determine the amount of shim or riser block that we need to put underneath the sign bar in order to give us a specific angle. Remember, all of your trig functions are located in your machinery's handbook. Again, it's an excellent reference source for setting angles based on trig factors. A neat accessory when working with a sign bar is to use an adjustable parallel. Simply set our adjustment to whatever height designated by our reference source, insert it underneath the sign bar, and now we've established the correct angle. Lock our adjustable parallel in place. We're ready to set parts on that location, machine whatever angles we need to based on our sign bar calculations. You can also use the sign bar as an inspection tool. If we had a specific angle that we were machining on a part, we needed to reference that, we simply dial our sign bar into place. We can use a height gauge. We can also use an angle block to check those dimensions as well. If we sight down something, if we look closely now at that parallel surface, okay, we can see just how precise of an angle we actually cut. The eye itself can usually see 1 to 2 thousandths without a problem in terms of light or angle when we have something against it as a backer. Anytime we have a straight edge, we can also use a straight edge in terms of checking something. The machinist square that we showed you earlier, again, is an excellent reference on the layout table for checking perpendicularity of parts. Keep in mind the surface table is extremely flat, so it becomes a workbench itself. We want to take good care of our surface plate. We don't put any harsh solvents on it. We don't scratch or scribe on the plate itself. coating it with a little bit of WD-40 or spray oil, keeping it clean and slick, is a nice advantage. Also keep in mind when looking at something, as we hold it up to the eye and look, if we have light as a backdrop, that allows us to check the flatness of a part as well. A long straight edge is pretty handy as well, and again, the surface plate being flat and true also becomes a straight edge. These things, again, with a little ingenuity, allow us to check parts and pieces. A 1, 2, 3 block, we use those in the mill as a parallel. They also are a useful accessory on the layout table in conjunction with our machinist square. We can set a part in place, locate it with the square, check it for flatness and perpendicularity, all at the same time, any position that we want. Another useful tool is our contact points. Remember, we talked about taking an in-mill stub, sending it off to the grind shop and having them grind a sharp 60-degree point on it. When we've done layout work, as in our layout block, this would simply go in the mill. We would simply mount our sharpened point in a drill chuck, come over to our scribe line, locate it, and we're ready to drill if it's a non-critical part. So if we're doing fast work, that's a good tip to keep in the back of your mind. Next, we've got radius gauges. Remember, we machined some specific radiuses on our test block. If we were to check those, or if we were in doubt as to the type of radius that we were dealing with, we have a complete set of radius gauges at our disposal. Okay, let's take a few minutes and go over how to properly use the radius gauge. Little corner that you see is for checking an exterior radius. This is for checking an interior radius. Let's say we've taken a ball end mill and we've machined a groove or a slot in something and it needs a specified radius. Again, for checking an exterior radius, simply set that over the part. Let's take a look at our block now and check some of the radiuses, and you can see the radius gauge in application. Okay, we can see the radius we've cut is quite a bit smaller than what we have in this specific gauge. Now we'll use a 13/16 gauge. Just a little bit tight. We can see the light underneath it, so it's a very precise way of measuring a radius, or using as an example to call out a radius on a part that we may have designed and we want to send out for additional machining. We can also use the end of the gauge again as an exterior radius, rotating it over the part. Obviously, if we were to put our 1/4 inch radius gauge, we would match our radius perfectly. Remember, we machined these surfaces with a 1/4 inch rounding end mill. All right, that pretty well covers the use of the layout table, some different types of inspection tools. Keep in mind the level of inspection that you need to obtain for the parts that you are machining. Dial indicators, test equipment is very expensive depending upon the application. Try and use the existing tools that you have available. Our dial calipers, a good layout table, a height gauge, a micrometer, radius gauges, an angle block, our sign bar, are all tools that we can use very effectively in establishing the quality control on the parts that we're manufacturing.